All right, hello everyone. Welcome to my channel. This is an educational channel dedicated to mostly the esoteric and the obscure, but the centrally important things that are unknown to most people, but if they were known, they would be able to affect our lives in quite positive ways. Today is the 160th video that we have done on the reciprocal system of theory from Dewey B. Larson. And Mr. Larson lived in the 20th century, died back in 1990, and put out many, many books on his reciprocal system. The idea behind the reciprocal system is that we live in a universe not of matter and not of energy, but a universe of motion. And matter and energy are merely two specific kinds of motion, as are really all other scientific phenomena, such as pressure and charge, magnetic and electric, and force, acceleration, and capacitance, and many, many other things that are also, when you break them down, they are motions. And motion for Larson was the relationship between space and time. Basically, space and time are fractions. Motion is a fraction, and space and time are the numerators and denominators. So either time or space is the numerator, and either space or time is the denominator. And space and time are therefore basically generalized reciprocals of one another, in the same way that 2/3 and 3/2 are reciprocals of one another. And so when you invert one, you can get the other. And so what we have is a situation where both time and space are identical to each other, except that they are reciprocals in motion. Both time and space don't really have any independent existence, except when they are together in motion. Both time and space have their coordinate aspects, meaning that they are 3 or more dimensions. And both time and space have their clock aspects, meaning that they progress. They're always moving forward, getting later and later and later in time, and getting farther and farther and farther apart in space. And both time and space come in only discrete units, meaning that there is a minimum unit of time and a minimum unit of space, and below that, you don't have that. You don't have those things. And that 1 unit of time, 1 unit of space in 1 unit of time is the speed of light. And so the speed of light is really the background. It's the one. It's the unit, the origin even of the universe. And that unlike what Einstein says, where he says that the speed of light is the maximum speed of the universe, in Larson's universe of motion, it makes sense that motion is the origin, and something in motion is the 0 point, so to speak, of the universe, where most reference systems measure from 0. In Larson, he has something that's called the natural reference system, and that natural reference system makes its measurements from unit speed, or the speed of light. And So there is an entire half of the universe that's moving slower than the speed of light, and half of the universe that's moving faster than the speed of light. Larson calls those the material sector and the cosmic sector, respectively. Einstein only really understood the material sector, and so when he said that nothing moves faster than the speed of light, he's right as far as the material sector is concerned. But in the cosmic sector, it's more like nothing moves slower than the speed of light. And now we don't know much about the cosmic sector, but we have the potential to, because what goes on in the cosmic sector is the exact reciprocal of what goes on in the material sector. So if we know something about the material sector, all we have to do is invert the relationships of space and time, and we get exactly what's going on in the cosmic sector. So it's a powerful, I guess the term would be extrapolation that you can make from what you know about the material sector to what you're trying to find out about the cosmic sector. Now, we are looking at his 1979 book that's called Nothing But Motion, and we've just been reading through it. This is about the 31st episode of that, and we're in chapter 7 that's called High-Speed Motion. Now, high-speed motion is basically motion beyond the speed of light, and or at least close to the speed of light, relativistic motion. And he's been going over some of the history of science, in particular relativity theory, and where it falls short, the various issues that it has, and how that it's been basically accepted unscientifically by the scientific community because it provides answers. It provides mathematical answers to questions, but it does not provide conceptual answers. It doesn't give us the why part of the equation or how. It just gives us, it's just kind of like, just plug in the numbers and you don't even think about why you're doing that, or plug in the numbers and just take the answer and don't question it. Larson is questioning it, and he's calling out these scientists, as he does quite often in his books, for their very unscientific approach to things, you know. And so right now he was going over an analogy that had to do with the Lorentz contractions. You know, if you're familiar with relativity theory, Einstein uses these contractions that were originally derived by this guy Lorentz, and they basically give you kind of the amount of time that gets distorted or by high-speed motion. So this plugs into what Einstein called the twin paradox, where you have two twins and you send at birth, and one of them you send in a spaceship out at nearly the speed of light, and then when the spaceship gets back, and the other one stays on Earth, and when the spaceship gets back, the one in the spaceship is still a baby or still very young, and the other one is an old man, because the experience of time passing at high speeds is shortened, if according to the relativistic theory, and the Lorentz contractions are mathematical fudge factors to show you how much time is shortened or lengthened. Okay, now so he was just going into this analogy, and we read part of this, but we're going to go back and look at this analogy and then keep going. Okay, let us assume a situation in which the property of direction exists, but is not recognized. Then let us assume that two independent methods are available for measuring motion. one of which measures the speed and the other measures the rate at which the distance from a specified reference point is changing. In the absence of any recognition of the existence of direction, it will be presumed that both methods measure the same quantity, and the difference between the results will constitute an unexpected and unexplained discrepancy, similar to that brought to light by the Michelson-Morley experiment. An analogy is not an accurate representation. If it were, it would not be an analogy. But to the extent that the analogy parallels the phenomenon under consideration, it provides an insight into aspects of the phenomenon that cannot, in many cases, be directly apprehended. In the circumstances of the analogy, it is evident that a fudge factor applicable to the general situation is impossible, but that under some special conditions, such as uniform linear motion following a course at a constant angle to the line of reference, the mathematical relation between the two measurements is constant. A fudge factor embodying this constant relation, the cosine of the angle of deviation, would therefore bring the discordant measurements into mathematical coincidence. It is also evident that we can apply the fudge factor anywhere in the mathematical relation. We can say that measurement 1 understates the true magnitude by this amount, or that measurement 2 overstates it by the same amount, or we can divide the discrepancy between the two in some proportion, or we can say that there is some unknown factor that affects one and not the other. Any of these explanations is mathematically correct. And if a theory based on any one of them is proposed, it will be confirmed by experiment. In the same manner that special relativity and many other products of present-day physics are currently being confirmed. But only the last alternative is conceptually correct. This is the only one that describes the situation as it actually exists. When we compare these results of the assumptions made for purposes of the analogy with the observed physical situation in high-speed motion, we find a complete correspondence. Here, too, mathematical coincidence can be attained by a set of fudge factors, the Lorentz equations, in a special set of circumstances only. As in the analogy, such fudge factors are applicable only where the motion is constant, both in speed and direction. They apply only to uniform translational motion. This close parallel between the observed physical situation and the analogy strongly suggests that the underlying cause of the measurement discrepancy is the same in both cases. That in the physical universe, as well as under the circumstances assumed for purposes of the analogy, one of the factors that enters into the measurement of the magnitudes involved has not been taken into consideration. This is exactly the answer to the problem that emerges from the development of the reciprocal system of theory. We find from this theory that the conventional stationary three-dimensional frame of reference correctly represents locations in extension space, and that, contrary to Einstein's assertion, the distance between coordinates in this reference system correctly represents the spatial magnitudes entering into the equations of motion. However, this theoretical development also reveals that time magnitudes in general can only be represented by a similar three-dimensional frame of reference, and that the time registered on a clock is merely the one-dimensional path of the time progression in this three-dimensional reference frame. Inasmuch as gravitation operates in space, in our material sector of the universe, the progression of time continues unchecked, and the change of position in time, represented by the clock registration, is a component of the time magnitude of any motion. In everyday life, no other component of any consequence is present, and for most purposes, the clock registration can be taken as a measurement of the total time involved in a motion. But where another significant component is present, we are confronted with the same kind of a situation that was portrayed by the analogy. In uniform translational motion, the mathematical relation between the clock time and the total time is a constant function of the speed, and it is therefore possible to formulate a fudge factor that will take care of the discrepancy. In the general situation where there is no such constant relationship, this is not possible, and the Lorentz equations cannot be extended to motion in general. Correct results in the general situation can be obtained only if the true scalar magnitude of the time that is involved is substituted for clock time in the equations of motion. This explanation should enable a clear understanding of the position of the reciprocal system with respect to the validity of the Lorentz equations. Okay, so listen to me explaining this over and over again until you get it, is basically what he's saying. Because the explanation should enable a clear understanding, but you may have to repeat the explanation several times before it kind of sinks in, because again, he's using a lot of unfamiliar terms and unfamiliar concepts and difficult visualizations. And, you know, a lot of times the difficulty with Larson is that he's trying to help you unlearn certain things, and what you have already learned in many cases serves as an interference for you to be able to learn his stuff. His stuff is simpler than the legacy science stuff, but the legacy science stuff complicates learning Larson because they're so different that you have to unlearn certain things before you can really have the space to learn Larson's. Okay, back to his commentary, his book. Inasmuch as no method of measuring total time is currently available, there is a substantial amount of convenience in being able to arrive at the correct numerical results in certain applications by using a mathematical fudge factor. In so doing, we are making use of an incorrect magnitude that we are able to measure in lieu of the correct magnitude that we cannot measure. The reciprocal system agrees that when we need to use fudge factors in this manner, the Lorentz equations are the correct fudge factors for the purpose. These equations simply accomplish a mathematical reconciliation of the equations of motion with the constant speed of light. And since this constant speed, which was accepted by Lorentz as an empirically established fact, is deduced from the postulates of the reciprocal system, the mathematical treatment is based on the same premises in both cases and necessarily arrives at the same results. To this extent, therefore, the new system of theory is in accord with current thinking. As Percival Bridgman once pointed out, many physicists regard, quote, the content of the special theory of relativity as coextensive with the content of the Lorentz equations. Feyerabend gives us a similar report, quote, it must be admitted, however, that contemporary physicists hardly ever use Einstein's original interpretation of the special theory of relativity. For them, the theory of relativity consists of two equations, or two elements, the Lorentz transformations and the mass-energy equivalence. For those who share this view, the results obtained from the reciprocal system of theory in this area make no change at all in the existing physical picture. These individuals should find it easy to accommodate themselves to the new viewpoint. Those who still take their stand with Einstein will have to face the fact that the new results show, just as the clock paradox does, that Einstein's interpretation of the mathematics of high-speed motion is incorrect. Indeed, the mere appearance of a new and different explanation of a rational character is a crushing blow to the relativity theory, as the case in its favor is argued very largely on the basis that there is no such alternative. As Einstein says, quote, if the velocity of light is the same in all coordinate systems, then moving rods must change their length. Moving clocks must change their rhythm. There is no other way. End quote. The statement by Millikan, quoted earlier, is equally positive on this score. Quote, the status of an assertion of this kind, a contention that there is no alternative to a given conclusion, is always precarious because, unlike most propositions based on other grounds which can be supported even in the face of some adverse evidence, this contention that there is no alternative is immediately and utterly demolished when an alternative is produced. Furthermore, the use of the no alternative argument constitutes a tacit assumption, a tacit admission, that there is something dubious about the explanation that is being offered, something that would preclude its acceptance if there were any reasonable alternative. I believe that is actually Larson's paragraph there. But we're going to stop there. I think we're going to wrap up this chapter in just a few paragraphs, but that's kind of the main point that I think he's moving toward here, is that, you know, Einstein's special theory of relativity is really only accepted under duress because there is no alternative. If you've heard something like that before, having to do with anything in the current situation in life, I wouldn't be surprised. But, you know, Einstein is basically saying, take it or leave it because there's no alternative. And that's not science. Okay, have a great day. We'll see you tomorrow.